is the sixth module of SQL Server Learning series is going on, and in this video we will discuss about the indexes. Index is a very important part of the SQL Server, and index is a structure on the disk which is associated with the table or an index view. This index structure will speed up the retrieval process of rows of records from the table or index. Index is using like this kind of structure. In this structure, there is the top level, which is called root level, and there is the intermediate level, which is the non-leaf level, and there is another level, which is this below blue line, which is the leaf level, and the leaf level is also called the data or index page level, and the index structure is known as this B tree structure, and SQL Server uses the B plus tree structure because B tree structure is a balanced tree, while SQL Server rebalances its indexes, so it's a B plus tree structure. And this in this beat tree structure, the root level contains the bunch of records, and these records are used by the SQL Server storage engine to go to the next level. SQL Server uses these records to navigate to the next level, and from this next level, which is the non-leaf level, also have the bunch of records. Each page has contains the records, and SQL Server storage engine uses these records to decide to which way to go down to the leaf level. And on this leaf level is either is there is the data or the index pages. So this basic structure is common among all the index types. We will get this index structure by an example, and this we have already created one table, country table in our database in the previous video. What we will discuss this example to explain this index structure. Here is our trading database, and in this trading database we have our user defined schema HR, and we have the user with this name which belongs to this schema, and by using this user and schema we have created a table country, and in this table we have created the primary key on the country ID, and primary, when we creating the primary key, it's by default creates the cluster index if there is no and already exist on this table. So we have inserted these values in the script in the country table. So now we will use one of this value to explain the index structure. So this is the example of this index structure, and here we will execute one query, select name from hr.country where country ID is 15. So when we will execute this query, SQL Server how it will use this index structure to retrieve this value, because we already have created an index on this country ID. So SQL Server will use the index structure. SQL Server will go to the root level, and from the root level, SQL Server knows that where are these pages which contains the index are located in on the memory. So from the root level, SQL Server will came to know that this index exists from page 1 to page 200, and SQL Server, the storage engine knows how to go get down to the next level. So it will use this page 1 to go to this index non-leaf level, and here it will see that this page contains two information of two pages, P1 which is located on this address, and P2 which is located on this address. So the storage engine will decide to which way to go down to the next level. So SQL Server will, the storage engine will decide to go to the right way, and the right way it will go to the P2 pages, and these arrows indicate the page addresses. So this is the P2 page, and here SQL Server, how it will search inside the page to find out this 15 value. It will use the binary search method because these all values are sorted. This is the cluster index, and these all values are sorted. So SQL Server using the binary search, and this binary search SQL Server will pick the middle value of this page. Like in this case, the middle value is 14, and SQL Server will match this middle value with the value which is coming in the search, which is 15. It will match that 15 is equal to 14. No. Okay, this 15 is greater than this middle value or less than? Okay, it is greater than. So it will leave this part and it will go into the down part, which is the greater than. So again, it will take from this part the middle value. This is the this value position is 5 and total values are 9 for. So 5 plus 9 divided by 2 is equal to the seventh position. On the seventh position, SQL Server will find the value 16. So it will match this middle value 16 to the value which is in the search. So 15 is equal to 16. No. So it is not matching. Then again SQL Server will see, okay, well, the value which it need to search is greater than this middle value or less than to this middle value. It is less than this middle value. So it's SQL Server engine will leave this part and it will search in this part. Now there is only one value, and this value will match to this searching value, and it will retrieve the this value. The storage engine will retrieve this record from this value, and which is the this name of the country, and it will give to the query executor, and query executor will return to the client. So this is the traversing in this way in the index tree structure, and index tree structure using the binary search for to retrieve this value. So there are two kinds of basic indexes exist. One is the clustered index and another one is the non-clustered index. Clustered index is a sorted list. When we define a clustered index, the records in the table are physically sorted on the base of the key of the clustered index. And when we are defining a primary key, the SQL Server automatically create the cluster index on this primary key if there is no already any clustered index exist. There can be only one clustered index in a table. So this is the structure of the clustered index, and this calendar, this is the this is the index metadata from where SQL Server will get the information about the root page, and this is the root page, and this is the intermediate page, and this is the leaf node. On the leaf node, SQL Server differentiate with the other indexes with the cluster index only on the leaf level uh, pages. So in case of in cluster index, this leaf level is contains the actual data of the table. It's the table data which we have seen here in example. This is the table data. This table data in case of clustered index is exist on the leaf level. On this leaf level is the actual table. But in case of non-clustered index, this leaf level is the pointers which are pointing either to the cluster index or to the heap. So this is the script which we used earlier. We already created a country table, and in this country table, on this column, uh, three car country code, we created a unique key. When we creating a unique key, it's creating a non-clustered index. So if we'll go on this table here in the enterprise manager, we can see here the two indexes. This is the cluster index, and this is the non-cluster index which is created for this unique key three car country code. When we creating a unique key, it's creating a non-cluster index by default. And so this non-cluster index structure is like this. This is the non-cluster index structure. It's similar to the cluster index. There is the index metadata. From the index metadata, SQL Server Storage Engine will came to know about the root page, and from the root page, SQL Server will go to the next level. And this non-cluster index have a structure separate from this data rows. In the non-cluster index, the non-cluster index contains the key values. These are the non-cluster index keys. Key like we have created the here in this table, the non-cluster three car country code, and this country code, these key values are exist here in this non-cluster index. Here these key values exist, and this key value for each key value points to the data row. This key values of the non-cluster index points to the data row, and this pointer is known as the row locator. And now this row locator can point to a heap or can point to a cluster index. A heap is a structure without any index, or heap is a structure without the cluster index. If there is no cluster index, then it is known as heap. So this row pointer could point this data row either on the heap or either on the cluster index. So basically, the is using these some methods to traverse through these index structure. These known as the access methods, and there are these access methods are the table scan, or index seek, or index scan. This the first access method, the table scan. If the SQL Server don't have the cluster index on the table, then it will use the this table scan method to search the values. And then there is the other method is the index seek method. A seek access method using an index structure. That's when the seek method SQL Server Storage Engine will use. It will touch only those rows which are qualifying in the search criteria. Or like this one, this is the root page. SQL Server will find the information from this root page to the down level, and from this the intermediate level, SQL Server will find to which way to go. From there, it will decide to go to the right side, and from the right side, this is the page, and in this page, SQL Server will retrieve only those records which are qualifying according to the search criteria. And this method is known as the index seek method. And the third one is the index scan. Index scan and table scan is almost same. Both are touching the every scanning are touching the every records on the leaf level, but the index scan has the index on this structure, while the table scan is scanning on the heap structure. So now we will explain all these access method by an example in the SQL Server Query Analyzer. We will go to the Query Analyzer, and we will see this. We will check the table scan example and index scan example. We have created the country table, and when we created the country table, we also created this primary key on the country ID, and by creating the primary key, a cluster index is automatically created. So on the country table, that one cluster index is exist on this country ID, and we will create an other table like country 2 and we will not create any index on this table. We will bypass the cluster index on this country table, and if we will not create the cluster index, then the structure will be the heap, and then we will see the access method, how it's work on this heap. So first we will create the table without cluster index, and we will insert the values in this table using this script. So we have inserted 250 values. So now this the second table, which name is country 2, this has no index. We can check from this uh, here that this table has the index or not. We will refresh, and then from the indexes we can see there is no any kind of index on this table. So this is a heap structure. Country 2 has a heap structure. So first we will execute this query, and we will include the query execution plan. From query execution plan, we will came to know about either this query is using the index scan or table scan. So this is the query execution plan we will use, and now we are going to execute this query, and this query we will use the country table which have the cluster index on country ID. So when we will execute this query, it will bring all the records which have in this query, and from the execution plan we will came to know which method is used to retrieve the values from this table. This use the index scan method. This is cluster index scan method, because the cluster index exists on this table. So the storage engine use the cluster index scan method. Now this we will execute this query, which is the heap structure, and we will see the storage engine which access method will use to retrieve the records. So we will execute, and it has the same records 250, and in the execution plan the this information is given us that this is the table scan. So the first one is the index scan, and the second table is the table scan because it is a heap structure. We will execute both query at the same time, and we will see the execution plan for both. The first plan is for the first query, and this is the cluster index structure. So here is the index scan, and the second one, which table have the heap structure, is the table scan. So the SQL server using these access method to retrieve the values from these tables. And there is a third access method is the index seek. And when we are giving any particular value or some range of value, then SQL Server may use the seek methods. Like this example, we will see in this query, we are asking to the SQL Server to bring the country ID name from a chart country where country ID is 1. So when we executing this query, so we'll see which method SQL Server is using. So here only one value is coming, and SQL Server is using the index seek method to retrieve the value from the index structure of this table. Or we can give the range of values like this, that country ID bring all those records which have the country ID greater than or equal to 1 and less than or equal to 50, and we will see which method SQL Server it will use. So the storage engine is retrieve the 50 records out of 250, and it's using the cluster index seek method. These are the three methods which we used here. One is the table scan, one is the index scan, and the third one is the index seek method. So in this module, we learned about the indexes, We studied the structure of the index, and we know how many types of indexes are there, and we seen